In example 10, we're asked to rearrange this expression 2 log base 5x of 25xy squared into one of these expressions. So we're going to look at these one by one. We're going to look at a first. Okay, now when we look at a, this can't really work because we have a times 2 in the original log, and this ends up being a plus 2. That doesn't work because these are incompatible. Okay, so there's no way we can get this 2 on the outside here, somehow converting that times into a plus. Okay, so we're going to say that a does not work because the times just can't all of a sudden become plus. If we take a look at C, what's happened in C is that we have taken the base in the argument. Okay, so I've taken this argument and the base, and I've just divided those together, and I ended up with the new argument. Okay, so just combining base and argument. First of all, base and argument are on opposite sides of the equation when we set up the exponential expression. So we end up with 5x to some power, we'll call that power a, equals 25xy squared. Okay, so we just can't all of a sudden divide those together. They're not compatible parts, so by doing that, it's not going to work. Okay, so we're going to eliminate C. We take a look at D. Now D, what we've done is we switched the base and the argument. Okay, so we started with this base, and that argument becomes the base, and this base here becomes the argument, and by doing so, we're saying that the times 2 becomes divide 2. Now there is this property that if we, this one here is the one I'm talking about, if we switch the base and argument, we can actually write this as a reciprocal. Now, if we're going to use this, we really should understand how it works, but it does work. And in this case here, this doesn't work because what we've done is we've just went from times 2 to divide 2. Well, that's not it's not taking the opposite power of whatever that power was. Okay, because the power is on the other side of that equation, other side of this log expression, so we'll call that power a. And if we were to write this as 1 over a, that would work, but this is not the case. Okay, that we just also went from power 2 to root 2 in this case. So this D doesn't work either. All right, that leaves us with B, and B is the one that works. And we can show how we go from that original expression into the B expression. So first of all, what we're going to do, the first thing is we're going to change the base. So we're going to change this base, log base 10. Okay, we're going to just change that to log base 10. And we end up with the argument 25xy squared over log of 5x. So that's how we get the 5x in the denominator. So we have this 5x down here and 5x down here. My next step is to split off this, the 25x with the y squared. So this becomes 2. And that 2 applies to both logs, so we end up with 2 log 25x plus, since it's multiplication, 2 log y squared. That's all over our log 5x. And then this power 2 on the outside can be applied out here, and we get our final expression, which matches what the answer there. We end up with, I'm just going to move that over. So we end up with 2 log 25x plus 4 log y, and that's all over log 5x. So the answer is B. Okay, taking a look at this example 11, we have a transformation occurring here, and we want to transform the xy coordinate from the original f of x into this one. So we're going to first of all split off our x transformation or y transformation. So we're going to start with the y. So everything on the outside is our change in y. So when I describe the change in y, we're going to first do a vertical shift of +6 that's inside the brackets. And then secondly, we're going to do a vertical expansion by ×2 because that's on the outside. So that's our change in y. Our change in x is going to be inside that brackets there. And everything is backwards. Now it's in factored form. So instead of adding 1, we're going to do, and dividing 3, we're going to do the opposite order and the opposite operation. So we're going to start with the divide 3. For the change in x, the divide 3 really is a horizontal expansion by 3. So that's going to happen first. And secondly, it's going to be a horizontal shift of -1. So this is in factored form. So in factored form, we always do the expansion compression first and shift last. So, but we could also think backwards and do it and get the same result. The easiest way for that one though is to recognize it is already in factored form. So expansion compression first, shift last.